Hey, good evening, everybody. We're back again for another installment of Meteorology Lab. And I'm going to look over to the right and make sure my levels are good. Hopefully everybody can hear this fine. If not, just let me know. Okay, let's go straight to our current weather. And of course, as I've pointed out, we don't have the 0Z data. So I don't have the high temperatures, but this is what the morning lows look like, and there's a lot of 60s across Texas. The highs, they've probably looked a little bit more like this. Let me find where the current data is. I'm a little bit behind this evening, so let me get this up to speed. Plot the base map here. You can see that coming up there in digital atmosphere. And there we go. Check out these temperatures we had today over the past hour. You can see lots of 80s. 88 there at Oklahoma City in late March. 85 there at Woodward, 91 at Canadian, 93 at Childress, just off the Caprock right there. So temperatures are running quite a bit above normal, but here's this cold front coming in from the north. And this is pretty characteristic of what we see in spring with these fronts sinking to the south. And this is a very shallow front. We can see up on the high plains. We don't have this northerly flow there at Lamar and La Junta. So you see that up there. Not much of a north wind there. So very shallow air mass, and it kind of recurves to the southeast up here in the higher plains of Colorado. And then further south, do we see the dry line? Not really. This is still pretty early in the phase of return flow. We've only got 40s and 50s coming up there through North Texas. So the moisture is not quite on tap just yet, and the dry line is not really configured just yet, but that'll come together maybe the next couple of days here. Okay, let's see what's going on elsewhere around the country. No 80s up there in the northeast U.S. They have recovered from that winter storm, but we can see cold front coming southward through Indiana, Illinois, and Missouri here. Things are still kind of cool there in Virginia and North Carolina, but we see 80s, coming here through Alabama and Mississippi. So somewhere in this sector right here, we've probably got a warm front. And let's see just where that is. Maybe running kind of like that, dividing these mid-70s and 80s from 50s and 60s in the Carolinas. And we've even got this recent thunderstorm here in Nashville, so probably looking at that warm front kind of like that. And here's the triple point in southern Illinois, and north of that we're going to have the occlusion. So that's going to extend up to the Great Lakes right there. So that's the configuration of systems that we have there in that part of the country. Okay, let's take a look at the flow across the country up at 500 millibars. We see that we do have troughing off the west coast here. So this is what's going to be coming our way later in the week. Once this ridge kicks on off to the east, then we'll start opening up these height falls. They'll be moving into the Great Plains. Through the Rockies into the Great Plains, we'll see the low pressure starting to develop in this region right here, and that'll really start accelerating the return flow from the Gulf, and we'll see the low-level jet start developing in that region. And that leads to a very good question. What does it look like in advance of a storm system? Like if we have an outbreak coming up later this week, what would that look like at 500 millibars? Well, I've got a few charts up here for us to look at. Many of you are familiar with El Reno. Back on May 31st, took the life there of Tim Samaras and his son and Carl Young. And we'll take a look at what kind of upper air patterns set up right before that thunderstorm outbreak. This right here is May 24th of 2013. And you can see, yeah, some very strong troughing on the west coast and very strong ridging, very high amplitude pattern here. Now, the outbreak, the thunderstorm in El Reno was on the 31st. This is the 24th, so let's check out what happened over the next several days. Well, as you can see, kind of a persistent trough out west. We're up to the 27th, and now the 28th and the 29th, and you see that trough, the deep shortwave trough starting to come across the Rockies right there on the 29th. And there's the base of that coming into Oklahoma. And then on the morning of the 31st, there it is right there, affecting Oklahoma City. So right before that, if I back this up, you can see this long period of westerly flow across the Rockies, and that helped to build a little bit of moisture return from the Gulf there. So 30 to 40 knot flow there at 500 millibars. Let's check out one more example. And I'm not going to really mention this immediately. I want to kind of maybe leave it for some of you to guess, but we see a polar front jet well to the north along the Canadian border. And not much going on in Texas and Oklahoma, just this very weak oscillation here, maybe some indication of a subtropical jet to the south. A couple of troughs right there. And we see the flow picking up here a little bit, 50 knots there at Chihuahua, so maybe indicative of subtropical jet a lot higher aloft. But we see the flow picking up through here, and yeah, maybe 20 to 30 knot flow through here. And now we see the base of the trough making its way into the Rockies, the Four Corners area. And this is the morning before the outbreak. This storm here, this was May 4th of 2007. This was the Greensburg storm. Affected that location right there. So we can see we don't need a whole lot of flow to really get things going. As you can see here, we had 40 knots at 500 millibars. And we have this very strong diffluence. Let's take a look at a couple more outbreaks real quick. Some of you may have noticed the date, but others maybe not. But I'm not going to mention this one either. Okay, so we start out with a large cutoff low in the California, Arizona, Nevada area here. This is 2 days before the outbreak. And we see a jet stream rounding the base of this low right here. 50 to 60 knot flow right in that region right there. You can see 50 knots right there at Midland. And then over the following couple of days, 50 to 70 knot flow, El Paso right here. This is about 18 hours before the severe weather. And we see the main low move on up to the north. And on the back side, we've got this 40 to 50 knot flow. And this is on the morning of the outbreak. And this was in Oklahoma. This was May 3rd of 1999, the Moore F5 tornado. And I'll back this up to the previous morning. You can see the dynamics looked a little bit better on the day before, on May 2nd. 50 knot flow there at Oklahoma City. Let me zoom this in a little bit. Okay, that's not going to work out too well. Anyway, you can see the polar front jet in the base of that trough right there. And this was a potential severe weather day, and I was actually out chasing that day, and it turned out to be a bust around Enid. And it was actually the day after where we really got the severe weather here. So sometimes the day before or after the big dynamics is when you get your tornado action there. So anyway, those are some upper air charts to look at, to kind of be familiar with as we get into spring here. And let's check out right now what's going on here with the thickness. So anyway, you saw earlier how the fronts were laid out. So we know that there's probably cold front through here, warm front through here. And yeah, that is kind of painted out here by the thickness gradient. You can see that very strong gradient right in here and a weaker gradient right in this area right there. So that corresponds pretty well with what we have on the surface plots there. And here comes our next front out from the west. And the location of the warm front, that's kind of difficult to place, so I might go with Oregon here. So anyway, this is the next system coming in from the west there. Okay, soundings. Yeah, let's check that out real quick. We know that things are pretty clear here at around the Fort Worth area. Let's see if we have an evening sounding. Yeah, it looks like we do. So here's the Fort Worth sounding. You can see it's very dry there. Moisture line very far apart from the temperature line, and we can see the column is very warm. Not really much of an inversion. Maybe the subsidence inversion right here. You see how the mid-levels are kind of spread out like that. That's a subsidence inversion. That's from sinking in the mid-levels through this layer right here. And as you might expect, that kind of builds the cap there. So that helps to reinforce decapping. So not only do we need warm air from Arizona and New Mexico, but subsidence can also play a factor there. And the tropopause is pretty high up there, up at about 37,000 feet. And let's take a look at a couple more soundings. Greenville, Spartanburg, we know that they're northeast of the warm front. So there's the Greenville sounding, and yeah, you can see the frontal inversion right there. Top of the cold layer, up at about 7,000 feet there. And we can see that the flow down under it, this is some southwesterly return flow, just northeast of the warm front. And up above that, we can see the flow is out of the northwest. So if we take our configuration of frontal systems, they look like that. Greenville, Spartanburg is right there. We can see that upper level flow is out in the northwest. So the upper air patterns, they're kind of open. We don't have a whole lot of really closing off of that low that would give us south flow aloft. So this is kind of one way we can kind of visualize the upper air patterns looking at just the sounding there. And you can see on the 500 millibar chart, yep, things are pretty well out of the northwest there over the Carolinas. Okay, let's look at the upper air dynamics, and while these charts come up, I'll take a look at the chat and see what's going on there. There you go, there's something to look at right there. And let me go through the chat. Have Andrew and Sue right there on time, one of our first viewers as usual. Andre Gulbis, that's a new name there. Hello to you. Good, you can make it in here. Jason Boggs is here. First day of spring. Wow, I didn't realize we were up to spring here, but it certainly feels like that. Kevin McKinney is here. Tree Nelson, Fun with Tech. Andrew, Kevin McKinney, Alexi is here. Sarah Wood checking in. Ryan Toomies is here. Tennessee and Dixie Alley look pretty active for Tuesday afternoon. Sarah mentioned it's 38 degrees in South Bend this morning. Severe thunderstorm at 3:15 with hail. Wow, it's more than we've gotten here. Oh yeah, I don't know how many of you looked at that severe weather, at that mesoscale analysis exercise, but you might want to give that a shot. It's in another video from Sunday. But what I'm going to do is I'm going to go through everybody's charts and kind of go through that during a video, during a, how do I want to say this? Yeah, I'm going to do a video. I'm going to kind of go through and look for mistakes on everybody's charts. So be prepared. There is going to be some critiquing. And whoever comes closest to what the best analysis looks like, there will be a free book that you will be able to get from that. Ron Chalfant checking in from Southern California. Ryan's asking how the jet stream pulling back north over the ingredients creates the explosive assist in the powerful EF4 tornadoes. I'm not exactly sure what you mean by pulling back north. I might need some clarification there, but the more detailed explanation, that might be a good idea for a seminar here. But if the explanation is kind of simple, I can probably maybe show you a few examples. Michael Burrell checking in here. And Fun with Tech says there will be many mistakes on his mesoscale analysis. Well, that's fine. I mean, this is going to be a learning thing, so please don't be afraid of making mistakes. That's kind of what we're here for, just to kind of learn from your mistakes. There's nothing wrong with that at all. Okay, here's the dynamics and the next wave coming onto the California coast. And we see that this is mostly associated with jet stream energy. So that right there, that's the next jet stream coming onto the coast. And there it is, breaking up into a couple waves as that comes on shore tomorrow morning, affecting mostly the San Francisco, Eureka, Arcata area. And then we get this other bit of energy. And this is going to be digging in here on the California coast, south of California, into Baja California around Thursday. So you can see there's some ridging there in the Great Plains. So warm air in the mid-levels, capping definitely in place. And a lot of the cap removal is taking place right in this area on Thursday, the 23rd. And then by the evening hours, we're looking at a situation like this. So most of the severe weather potential is going to be in the high plains on Thursday. So for those who are chasing, you're probably going to be heading to Amarillo, maybe Clayton, maybe down to Carlsbad. So right in that area right there. And then things will be coming out onto the plains. There's 18Z on Friday. I-35 is right in this area, so this is going to be an I-35 and eastward type of day here. and things move out on Saturday. Overnight through the Mississippi River Valley and then into the Georgia, Carolinas, East Tennessee area for Saturday evening. Actually, this may be even as far back as Alabama. I'm going to go with probably something like that for Saturday evening. Then for Sunday, everything will be pushing eastward off the coast, a little bit of a reprieve here, and then the next bit of energy comes into the West Texas area. So this will mostly affect probably areas west of I-35 on Sunday. And then by Monday, possibly some action up in the western Midwest area. And then here comes some more energy coming from California. And that'll be digging into Texas around midweek, around March 29th. And then another wave coming at us around the 31st and 1st. So we can see one bit of an energy right there around the 1st. Heading up into Kansas right here by 6Z on the evening of the 1st. And more energy coming into the Big Bend for the 2nd. But we can see that the flow is a little bit more backed aloft. And that means that the hodographs are going to be less curved, kind of like straight line, maybe splitting storms, that kind of thing. And especially with this much dynamics, probably we may be seeing a squall line that day if that pans out. Then things look pretty quiet after the 2nd, and next shot coming in here for maybe the 6th. Okay, Ryan is asking about Moore, Oklahoma, how the jet stream plays a role into feeding the strength of the extreme tornadoes. Well, that's pretty complicated. There is some, as we do get some of the energy in the Great Plains, the jet stream will definitely help feed the low-level jet. So moisture advection, that's going to be really huge. Let me see if I can show an example of that. Yeah, like right here. Strong low-level jet coming out of New Mexico into Kansas. So we're getting some good cyclogenesis in this area right there. And that's going to help accelerate parcels from the from the Gulf of Mexico northward. So that means moisture advection, that's going to bring moisture northward. And moisture is really critical in a tornado type situation. Also upper level waves. Like right here. We can see maybe a couple waves coming through here. Those can help focus. Those will help focus cyclogenesis down at the surface, and we'll get localized development of low pressure areas, like maybe right here in Kansas. And what we look for is the development of mesolows, really small scale lows, because that will help back the winds just northeast of those lows. And that's what will really get your hodographs to be kind of curved there in the lowest couple kilometers. Because to get that really strong curving in the lowest couple kilometers, you really have to have your mid-level winds out of the southwest, but your winds down at the surface need to be out of the southeast or east. So when you're like focusing those dynamics on too deep of an area, too large of an area, you end up backing the winds through a really deep layer, and you don't get that curving. So we really need good, strong, small-scale good small-scale response in the lowest levels of the atmosphere, and then have the mid-levels coming out of the southwest like that. So that's one factor. Also, we need low LCLs. And to get low LCLs, we have to have good moisture advection. So again, moisture is a big ingredient right there. And also very important is high instability, very high capes. So to get that, what we need is we need a deep lift through a deep layer. The release of potential instability. See, I'm sitting here trying to figure out how to do this without putting up a skew T, but maybe I need to do that. So let me bring up a skew T here. And I've got a couple soundings up here. Let me go to the El Reno day. El Reno. There's the upper air data for El Reno. This is a program called RAYOB, and this allows us to view skew T charts. And it's especially helpful for historical case days. I can go all the way back to the 1940s and pull up soundings. Looks like I lost that there. Let me try pulling that up one more time. El Reno. Okay. Region, United States. I'm going to pull up the sounding for Norman. And this is the El Reno day right here. This is May 31st of 2013 during the morning hours. Let me set up the diagram so it's a little bit more familiar. I'm going to set the top of that photograph or that diagram for 100 millibars. There we go. So you can see a very... Looks like I lost that there. Let me try that again. I forgot RAYOB here is very finicky with using the escape key, and I use the escape key all the time to draw on the charts. Okay, so you can see this very steep lapse rate right here from about 750 up to 200. And capes are very high. You can see 3,000 joules per kilogram. Now, going all the way back to what I was talking about with jet streams, the lift that we get with those jet streams helps to shape the instability aloft. And we get that through lifting through a very deep layer the air over a region. As you might imagine, if we lift this, we're going to get the release of latent heat. So we're going to end up with some fairly warm temperatures in the lower layers. But aloft, when we lift this upper layer, we don't have that effect of steep lapse rates. When we lift that, we get adiabatic cooling. So we get some fairly cool temperatures aloft as a result of that. So what that does is it helps to steepen the cold over warm conditions. So we end up with much cooler temperatures aloft, especially since the upper dynamics are focused mostly aloft at first. And then down here at the bottom, we end up with pretty warm conditions. So, as I mentioned, very cold over very warm at the surface. So that helps to steepen the instability there. So that's another way that the jet stream and the strong lift aloft really comes together there. Okay. Sorry about that. I'm kind of fumbling my way through way up here. Okay. All right, let's go to the forecast here. We'll look at the pivotal weather, at the thickness and isobars. Let me get this set up here. Okay, there we go. So starting out, right now this is the cold front. There's the warm front down in the southeast U.S. and a occluded front. So what's going to happen over the next couple of days? Looks like we got kind of a stationary front here through the central U.S. Here comes our next system coming on shore, and you can see that the thickness gradient pretty piled up through this area here. So we're going to see that kind of tighten up, and that's going to help what we're going to see over the next couple of days. We're going to see that gradient tighten up in Nevada, California, and Arizona. And once we see that moving into the Arizona, New Mexico area, right there, that's the cold front moving onshore right there. So around Thursday or Friday, that'll be crossing the Rockies here. And you can see that really taking hold there around Thursday evening. And we're probably going to have the dry line out ahead of that along the cap rock. So we can see that the GFS trying to break out a little precip there around the Amarillo area. But the main dynamics are pretty far back over the Rockies. But those will be spilling out very quickly, and we'll probably see the development of a squall line overnight in West Texas there. So that'll be moving across Texas on Friday. And hopefully the dynamics, well, if the dynamics coming out of the Rockies are pretty strong, we're just going to see a very strong squall line moving eastward. If the dynamics are kind of weak, we'll see more of a discrete line, and that would probably enhance the possibility of severe weather. Okay, so there we go. GFS going for a squall line across the Mississippi River Valley on Friday night. And then it's going for some development back further west on Saturday night there. So you see that one line kind of dying out, then a second line developing further west right there. So probably another little feed of moisture coming up from the south there. And then here we go with round number 2 over Texas on Monday and Tuesday. It doesn't look all that potent here on the surface map, but this discrete appearance is actually pretty significant for severe weather. That means less cell competition. And here we go. Another round coming together for Wednesday. This is the third outbreak. So that comes together in Texas Monday and Wednesday and Thursday around 29th or 30th. And then the next round setting up for Sunday the 2nd There it is right there. This is digging pretty far south into Mexico, and that comes up through Texas around the 2nd or 3rd. So we're getting into a pretty active pattern here starting later this week. And even more coming up for the 5th and 6th there, with the next bit of energy coming through the Rockies right there. Okay, let me see if there's anything else I got in chat. Read through all the messages here. Just give me a second. And Jason Boggs calling a target of Nara Visa, New Mexico. Yeah, that's right there around the Clayton area. Ryan is mentioning the May 31st of 2013 day, the El Reno. That would be a day to play over and over again from studying at every possible angle. Yeah, that's definitely one of the most... That particular storm, maybe I can bring that up real quick since we've got quite a few viewers here. I'm going to bring up May 31st in GR level 2 and let you all take a look at that. So I'm bringing up GR2 analyst. That May 31st storm was very interesting because it had one of the highest velocities I've ever seen in a supercell. There was a shear in that storm of over 200 knots. Okay, cases. Let me bring this up here. 2013 El Reno. TLX, and that was about 6 o'clock, I think. Around 6:30, I think. 2300 to 2346. Let's give that a shot there. Okay, the El Reno storm coming up here. You can see it right there, west of Oklahoma City. There's that hook echo. So this is one of the strongest supercells that I can recall ever seeing. Looks like a little bit of a left mover down there around Lawton. At least it looked kind of like a left mover there early on. So let me look at that first. It looked like a little bit of splitting. Yeah, that's a left mover right there. Anyway, we'll go up to the north part, to the Oklahoma City area. Let me back that up to the beginning. I think I grabbed this sequence here a little bit early, or a little bit late. Let me back that up a little bit. 2237 to 2332. Let me grab that here. But anyway, this area right here, that is where a lot of the chasers got kind of caught up ahead of that storm. That's where Carl Young and Tim Samaras got into trouble with it. Yeah, I think that's it right there, 2314. I'm sorry about that. I'm not kind of clear on exactly what time of the evening this happened. But I think I got it here. Okay, let me roll this through. Yeah, this is this here is wind. Tim Samaras got hit right around here. And you can see that tip of the hook there forming kind of a debris ball. If we switch over to spectrum width, you can see that debris right there. So yeah, it's a pretty good cloud there. And then the velocity's very intense there. Let me switch over to storm mode of velocity. Yeah, look at that right there. 65 out and 115 inbound. That was quite a mesocyclone there. Give me just a second here. I got somebody at my door. I'll be back in just a couple minutes, and I'm going to run a loop, and you can check this out. Give me just a second here. Okay, we are back. This is what happens when we run into 40 minutes, 15 minutes of overtime. But anyway, there's the El Reno storm. And I do have a separate video that I made about a year and a half ago that goes into the storm in a lot more detail. So you'll want to look on that on my channel. And I'm going to back this up so you can see the intense TVS coming together. You can really see that over the I-30 area here, or the I-40 area. And then that moves south of I-40, southwest of El Reno. And we can see this tracking southeast like that. And then we see the intensities really start picking up here. But again, keep in mind that this is about 3,000 feet up above the ground. So a very wide meso. And we're seeing here about 137 knots, no, 146 inbound right there. 146 in, 103 out. This is 250 knots of shear. I've never seen anything like this ever. And I'm going to put a dot right there over where the center of the circulation is. So this thing, yeah, it's right here. Big, I don't know, vacuum cleaner or whatever you want to call it, centered right in that area. And then that kind of shifts northward, kind of falls apart. I guess that's a little bit of occlusion going on. And then we get to the end of that sequence right there. So let me bring that back to where we had it earlier. And yeah, you can see spectrum width here, very high diversity. So we've got, what it's picking up on here is debris with a very high difference in velocity. So, and that's the result of different sizes of particles being lifted aloft, and they have different terminal velocities. They respond differently to the air at different sizes. So you end up with a very strong range of velocities there. And so we get this high spectrum width in here. So that's what we're seeing right there. And let's look at the storm aloft. Let's go up to a higher tilt. Okay, so now we're up at 7,000 feet. And then we start seeing this donut hole right there. So that's the updraft. And it's also basically the B-weir. It looks like another one right here. And then we start picking up the overhang right in this area right here. And I remember looking off to the northwest when this was happening, and there was a ton of lightning in here, just anvil crawlers everywhere in the storm. And let me give you a quick cross-section through that storm. There we go. That's the El Reno storm, and there you can see some very prolific overhang, very pronounced, extending down to the south, probably about 20 miles there. So there you go. Towering up to about 57,000, maybe 60,000 feet there. And yeah, I'm going to call that probably about 57,000 for a top there. So quite a storm there, guys. All right. So anyway, that's the El Reno storm. And that's probably about as much as I want to cover tonight. I've got some dinner here, so I need to go ahead and eat that before it gets cold. Let me take a last look at the chat here. Alexei, very intrigued with El Reno. A little bit of discussion here about El Reno. Alexei says if you look up the El Reno TED, that's exactly where they have a radar with spotter videos that have been synced up at the same time. Yeah, there's definitely been some good post-mortem analysis of this storm. Well worth checking out there. If Ryan says a few videos from different angles caught the true power of this tornado at maximum peak. And Skip Talbot has a few good video analyses of El Reno. Yeah, there's definitely some good, that's another chaser there to look up. The El Reno storm has several satellite tornadoes that fed off the main storm. From Michael Burrell 13 there. National Geographic synthesized videos. Jeremy Mattingly remembered El Reno had an anticyclonic tornado as well. All right. Okay, well, that's about all I got for tonight. We're going to have more tomorrow on the upcoming severe weather outbreak later this week. And I would expect later this week I'm probably going to do some interesting stuff with my schedule. I'll probably fire up stuff around afternoon and maybe take you through a little bit of hand analysis and show you how we forecast where the target's going to be. So we're going to look at doing that probably Thursday and possibly on Friday, depending on the timing of everything. Anyway, that's about all I got for tonight. Appreciate you watching, and we'll see you tomorrow.